Hello, my name is Kjell Prytz, and I will talk about the possible source to mechanical inertia. This work was published 6 years ago, and it's open access. So I will use the gravitational induction as the source of mechanical inertia. And this is in line with the Mach's principle, and I will work in a cosmological perspective. I will use the standard model cosmos, lambda CDM, apply the inductive force as derived from general relativity. I will apply retarded interactions since interactions take time. My objective is to investigate the equivalence principle and hopefully show that gravitational and inertial mass are equivalent. So general relativity can actually be approached through an analogy with electromagnetism, and that has been proved theoretically. This is the so-called GEM model, gravitational electromagnetism. In case of magnetism, it's rather illustrative to make this comparison. Magnetism appears, as we know, due to motion. And at rest, we also have an observer, of course, and at relative rest, there is the electric force only between these two identical charged objects. But when they move, there is a magnetic effect reducing the electric force. That's the way of viewing the magnetic effect. And we cannot distinguish between these two cases due to the principle of relative motion. In case of gravitation, we have an equivalent or analog dynamics. Magnetic effect appear, weakening the gravitational force. Relative rest, we have the usual Newton gravitational formula. In motion, general relativity shows that the force is decreased due to the magnetic effects. We have opposite direction of the forces in the two cases. So magnetism appears due to uniform motion of the objects. Now we have also a case of accelerated motion, and then we approaches the so-called inductive phenomena. Now, if I write down the formulas, we know from these are well known for electrodynamics, electric force, and the correction due to motion that we call magnetism is here. So this is a field-free description I use in the force picture of the dynamics, and these are the formulas for the two objects interacting with parallel motion, the same velocity v. Now, in case of acceleration, there is an inductive force. This is equivalent to Faraday-Henry induction law. So charge number 1 is accelerating. Then this is the force on object number 2. And this force is then in the opposite direction of the acceleration of object number 1. So the induction is an opposing force in case of electrodynamics, and this we all know when we turn on the battery of a circuit, and the charges experience an opposing force that we call induction. If we look at gravitation, we have Newton's gravitational law. We have the same magnetic correction. We have a similar inductive force in case of acceleration. But all forces are in the opposite direction, also inductive force. So when we accelerate object number 1 here, the v1 dt, then the force on object number 2 is in the same direction as the acceleration. And this is crucial for identifying inductive force as the source of mechanical inertia. Sciama was the first one to quantitatively explore this force and found that it gives a substantial contribution to inertia. However, he neglected this spurious factor 4, which cannot be obtained from direct transcription, but is a result from general relativity. This is in line with Mach's principle because of this 1/distance dependence here. When we perform a real calculation, we have to include all objects of the universe, and this amount of mass increases with r squared, so the force will increase with r, so the most distant objects will contribute most to inertia, and this was Mach's insight. It has to be like that. That is due to the fact that the inertia is not directional dependent. So this is promising. There are two conditions here: a force in the same direction as the acceleration of the other object, and that there is an increasing force with distance from the object. So how does it look for the in the maximally simplified situation where we have two objects? How does this dynamic works? Well, we accelerate object number 2 upwards. Then I go to the rest frame of M2. Then we observe an acceleration downwards of the other object. M2 is accelerating upwards in the rest. Then, since due to this acceleration downwards, there's an inductive force downwards on M2. M2 is accelerating upwards externally, so this is Newton's second law. And in the rest frame, these two forces have to be equal. So we have this equality, gravitational inductive force equal the Newton's second law. I have inserted here relativistic factor gamma depending on velocity u. This velocity u, that is the relative velocity between m1 and m2. Einstein was the first one, of course, as he is the first one of everything, to point out that this inductive dynamics of the general relativity is a source to mechanical inertia. And he actually pointed out that it's the source, because he couldn't imagine that there could be several sources. If there is one source, then this is the source. And he also noted the direction of the force, that it must be in the same direction of that acceleration for this conclusion to work. So this is a very good book, The Meaning of Relativity. Please check that, page 95. Now, in order to do the calculation, then M1 is not one single object. Excuse me. It's not one single object, but it is the rest of the universe. It's the rest of the universe. And it's very important since the most distant objects contribute most. So we have to integrate M1, including, so we have to include all mass elements of the universe. And for that we need a cosmological model, and that was not known for Einstein, so he could not do this calculation. Sciama tried to do it, but it was still much too early in 1950. But now, during 10 to 20 latest years, there have been several calculations using the cosmological models that are evolved. So we take this formula and we shall sum up all mass elements of universe here, M1. So here we have the two object formula. we model then the universe as spherical shells. We have then accelerated M2 downwards here, or then in the rest frame of M2, all other elements accelerate upwards. And then we integrate from 0 to the radius of the universe, given by our cosmological model. Acceleration here cancel on both sides. I divide by relativistic factor gamma, and then I integrate over universe volume. Here is the mass element corresponding to M1 here, density times volume element. We have the relativistic factor here, and then we have the distance between M2 and the particular mass element. Then we see that the mass element should be given at emission time, that is the retarded time, whereas the distance should be given at observation time. So there are two different times here in this integral that we have to handle. So I use the standard, today the standard cosmological model lambda CDM, which is Big Bang, and it contains dark matter, dark energy, and also radiation, and then the real matter, or daily matter. So there are 4 different sources to mass in this model that we have to take care of. The density of these different masses varies differently with time, but all of this is included in the model, which is parameterized. This velocity u, that velocity that I obtained from Hubble's law. So from this, I just multiply this distance with Hubble constant to get the velocity u. And actually, the velocities here that contribute that is velocities up to half speed of light. And this is the weakness of this calculation, because if I go back, you see we use linear general relativity. That means low velocity and weak field. And half speed of light, well, that is not maybe low velocity. So this is a weakness that can be improved. And what we can do then is to include higher order correction to linear relativity. And that I am working on at the moment. But in this approximation, the linear general relativity, the result is fairly good. We get a nice equivalence here, nice verification of the equivalence principle. So this kind of calculation has been done before, and the most important one, as I can understand, is that from Sultana and Casanas 15 years ago, who made a similar calculation. So I learned a lot from them. So, but the main difference is that they forgot this factor 4. They also don't use the relativistic factor here, but they have a cutoff in the integration. But the most essential thing is that they forgot the factor 4, so they got 25% here instead. So it's a very similar calculation. And it's a nice verification also that there is another group here who have obtained the same result in principle. So conclusions: the weakness, the low velocity approximation. We may in future improve the cosmological model, and this is a nice proof, maybe not of the equivalence principle due to the uncertainties, but that there is no doubt about that general relativity dynamics provides a source to mechanical inertia through the inductive force. So this is at least proven by me and several other groups around the world. And strangely enough, this is not pointed out in the literature because it's a important discovery. So please, if you are interested in this, take contact with me and we can discuss further. Thank you very much.